Okay, so ma'am, you can start now. Yes, ma'am, you can start now. Hello, Diksha, ma'am.
Hello.
Ah, yes, you can start.
Yeah, hello everyone, and welcome back to our webinar session series, which is we have planned for our upcoming session. So here we will be starting with DevOps and cloud mastering session, where we have Abhishek Kesari with us. He is going to give us a quick walkthrough or maybe to set up the context. If you are looking to start your journey either in cloud or in DevOps domain, so this is the right place. Here we will be answering all your open queries and questions which respective to your cloud and DevOps side, how you can enter into the IT or tech domain with these expertise or these skill sets. And we will be giving you a quick walkthrough. Also, some fundamental concepts will be clearing out over here. So, welcome Abhishek, and thank you for joining us today.
Yeah, thank you, Diksha. So, good evening, everyone. And let me share my screen. Yeah. So, today we are here to understand what all the components that we will be covering up with our upcoming batch. So, we will be starting up with our DevOps batch. Here, we will be covering up the two core components. In this lecture, it's some of the basics terminologies of the DevOps, as well as we will understand what we are going to expect from this course, or at the end of course what are all the deliverables that will be delivered to you guys. So with respect to this batch, so the first thing that I need to make clear is like there are no as such prerequisites. So if you have your system up and running and you are able to understand English as a mode of communication, then everything will work as you expect. So we will be starting from the core basics of the DevOps, the fundamentals of computer science we will be covering up. So at that time, you have to think in a way. It's not only just like any other DevOps course. I will be not directly jumping into DevOps. Okay, it's not like that. We will be directly focusing more onto end-to-end pipeline automation and that part. We will start from the development and slowly we will move towards the DevOps. So it's kind of a journey from the development to DevOps. Okay, it's not up to like we will be just learning about some DevOps tools and we will understand just tools and we will start using these tools. It's not like that. It's not gonna happen. So we will start from the development. Into the development, what I will be teaching you guys is a Python. Okay, so Python fundamentals along with some of the design patterns I will be teaching you. Okay, Python fundamentals will be there. When I say fundamentals, it's not like that just some syntax I will be explaining. When I see the when I say the Python fundamentals, we will be learning about the frameworks as well, such as Flask and Fast API. Okay, because these frameworks are at the end we're gonna need it to develop some kind of application. DevOps, I think personally, the DevOps is the last step in a project. I personally think that if you don't have any project, what all the things you gonna automate, right? So if you have to understand DevOps in a word, it's kind of automation. You can say it is nothing but an automation. Let me switch to somewhere else. It's a way towards your automation. Okay. Now to automate something, you should have something first. So that we will understand through Python and that we will try to build some of applications with the help of Python. Also, we will understand what all the types of design patterns that we can implement. Okay, so whenever you are developing an application, there are some design patterns that you need to follow. In short, there are some standard practices while designing the core application, right? So these core design patterns, ideally, no one is gonna teach you because uh, it's kind of a topic where you gradually understand while working. Okay, but I think this is one of the most important topic with respect to development anyone should understand. Okay, so design patterns helps us to design the softwares which are highly scalable. This is the main core intention of understanding the design patterns. So with respect to Python, we will be covering up um our Python syntax end to end. You will expect uh, from basic to advanced in the terms of the Python. Along with that, we will be covering up Flask as well as Fast API. Okay, both are micro frameworks with respect to Python, and we will be touching that so that we can build applications. Now, once application is built, then we can think of deploying uh, or we can think of like automation approaches. So when application is built, there are multiple tools that will be jumping into your way. But before you directly start working with the tools, you still need to understand some of the fundamental concepts of the development, like networking. Okay, so networking will be there. It's not like that you just written a code and it will start working out and you will able to go live. I don't think so that that's how it works. I don't think so. So we will be understanding networking from end to end, theoretical as well as in a practical manner. With respect to cloud, we will understand the practical aspects of the networking. Also, we will be touching up some of the fundamental theoretical concepts of the networking as well. So networking we will understand from basic. After that, there are some more things that we need to consider. Is like before we start with the core DevOps, the CI/CD part, you might have heard like CI/CD priorly, but if you haven't, no issues. We will cover up this part as well. Before we directly jump into there is some kind of things that we need to understand with respect to components. Components like whatever the components that are needed, whatever the prehistoric era of the DevOps that was there, how the people in earlier days were trying to make the applications that are highly scalable. That part, some prehistoric journey we will touch, not up to the very deep dive, but some overview we will take so that we will understand how better today's DevOps is than the earlier era. So here we will understand about the virtualization, the kind of applications that mainframe was using, and some other basics that we will understand. And then we will slowly start touching the cloud, why cloud has emerged so high, and how the Docker and Kubernetes has reshaped the scaling part. These things we will slowly try to understand. After understanding what I think, after understanding is like Python fundamentals, networking, we will directly start with some we will start after understanding this historic era as well. We will then directly start with some of the tools. Okay, so with respect to tools, we have too many tools, I can say, in the course. So we will be starting our days with the Docker. Okay, so we are limited to time, so I will slowly I will just give a high level overview of each and every tool, what we will be doing with respect to this tool, so you can have a better understanding. So with respect to Docker, if I have to say, Docker is something that will help us to package our application. It is something that will package our application. Now understand, what does mean by packaging? Okay, package or container, these are the words that are feasible to Docker as a technology. So when I say there will be Docker as a tool, so we will understand how our core application that we have written in Python, how we gonna package it or we gonna containerize it, and by using this containerization technology we're gonna make it as a platform independent. Now most of the guys don't understand the platform independent. What does it mean? So what I mean to say, maybe your Linux, Windows, any other kind of operating system anywhere on cloud or on physical on premise or on data center. Okay, some of the guys might be aware about these uh, terminologies, some of you might not, but understand there are different ways where you can run your application, right? So through Google Ads, you have seen that hosting gear is one of the website that helps us to deploy the application, and there is various other solutions that are there. DigitalOcean is also there. So similar to that, we will make our application in a such a way, this using the Docker, our application is compatible to run anywhere, any of the technologies that are the standard technologies are there, anywhere our application will able to run. So this is the core intention of the Docker. Okay, so actually when you start working with the Docker, you will understand this is very easy and friendly, and the Docker has played very important role in reducing the time period for CI/CD. So if you think in earlier days, the CI/CD was not like that we have today. So we will discuss this in more in course, but I can say it has reduced the 1,000 times. Whatever the time that is taken to release a feature is been reduced by 1,000 times. In short, Docker is capable enough to run an operating system within a fraction of second. Okay, so now if you compare, if you have a new device you bought up from the market and you want to set up a Windows, you will gonna take almost 3 to 4 hours to just set up the Windows. But what I am saying is like with the help of the Docker, you can set up or you can create your own operating system within a fraction of seconds and make it running. Okay, so that's how the role of the Docker is going to be. Now, if you see the K8s or Kubernetes, K8s is the short form of Kubernetes. It is something that has actually impacted the DevOps and the resiliency part. The resiliency that you see throughout the applications that are in the market is because of Kubernetes. What I mean the resiliency. So right now you can see we have traffic coming from the public to any application in crores of the requests. Still the application is able to handle that much traffic. In earlier days, if your application has a traffic or if the application has too many requests that are ongoing, application was crashing or something is happening with the application. But right now, if you take an example of Hotstar, they are able to serve the streaming capacity for 10 crore audience at the same time. Okay, so this kind of thing, the resiliency or what we say, um, the performance of the application has been improved because of this, and this is actually going to help us to achieve just a minute. Sorry. So if you understand with the help of EKS, you will, if you have to understand the EKS, you have to consider a term called as the performance or the resiliency. In a technical ways, it helps us to actually achieve the auto scaling in better way. Specifically, it is something called as the container orchestration tool. Okay, or we can say container orchestration tool. It is, and it is actually responsible for managing your containers, and containers are actually created by Docker. So if you see now, the relation is like Kubernetes is dependent on Docker. Okay, if you have the Docker, then you will understand the Kubernetes. And the Docker is dependent on the Python and the networking, because these are two fundamental things that we're gonna need while building an application or any kind of operating system if it is there, right? So that's how the hierarchy is ongoing. Now, with respect to Docker and Kubernetes, there are various ways that you can leverage these two tools. Earlierly, people were having data centers. Companies was creating their own physical data centers at their location, and using the data centers, they were trying to achieve the clusters of Kubernetes and Docker. What I mean a cluster for the time being, understand in a way that there are too many uh, physical hardwares that are assembled together to run a single program. Okay, now suppose if you have hundreds of laptops that you have into your laboratory, right? By some way or another, through wireless or wired mechanism, you connect these laptops together. Now, with the computation power of all these laptops, you are trying to compute something. Now, this connection or this bunch of the system is the system that we built with the help of this bunch of the laptops is called as the cluster. Okay, and what is the core advantage behind the cluster is like we can assemble we can assemble these systems together to achieve much higher computation than expected. Okay, than expected. And if you have to think in a better way, the cluster is actually something that will help us to also distribute the program in better manner, where we won't be having any kind of bandwidth issue. Okay, bandwidth issue in the sense, so suppose let's take an example. So you have written a Python program which is taking huge consumption in the terms of the RAM. Now your program is consuming around 12 GB of RAM, near real time consumption it is. Now you have two laptops, both are having configuration with respect to memory is 8 GB. So total you have 16 GB. Now when you assemble these two laptops in a way where they are actually sharing their memory, sharing their resources, at that point in time you will able to achieve, or you will able to run this program which is having size of 12 gigabits. Okay, so this is something that you can achieve through clustering techniques. And the cluster is not up to limited to this Kubernetes Docker. Cluster is all over. Okay, even if you change the field, even if you see data engineering, any other things, and kind of file systems are there, anything, cluster is all over. Okay, none of the single computing system is capable to perform after some significant resources. Okay, every single system has its own limitations. You cannot just scale a single system. Okay, so we will understand the clustering part when we will directly jump in there in the further sessions that we will be holding on. Now, right now the people has understood that these are the two main core important components that we need to leverage while working with our DevOps fundamentals. Now, if you see the provisioning part, or what I mean to say is, like, to run these systems, we need some kind of CPU, some kind of physical resources. Okay, these physical resources we can either bought, and we can set up our own data center, which is kind of a hectic and too much time consuming, that I personally think, and that the many other companies have also thought. So there are some companies that have already bought huge amount of resources, RAM, CPU, GPU, hard disk. These kind of resources they have bought and coupled together and created big clusters in the form of data centers. Now you can leverage the resources from these companies. Okay, so if you say there are the companies like Microsoft is offering a product named as the Azure. There is the AWS by Amazon. There is something called as the GCP from Google. So these three are actually the products that are there, which actually offers us these resources with very little rent, I can say, or payout. You don't need to set up any infrastructure on your own. You don't need to install, you don't need to physically configure anything. You just need to go to these products. You just need to create your login credentials, and whatever the tools that you will be using, whatever the RAM, CPU, GPU you will be using, only that amount of money you're gonna pay them. So there is no as such rock solid investment that we are making here. We are free to use whatever we want and how much we want. So suppose if you thought, let's take an example. So suppose if you thought earlier that your company might grow and you have invested your 90% of the wealth into the hardware components. Later on your product gets flopped. What you gonna do with the data center? So that was the business idea behind these three tools or these three products that we say. Here you are not actually investing to direct hardware. These guys are renting out their hardware resources to you. You will be using their hardware. You will be paying them a rent, depends whatever the things that you are using and how much you are using. So they are using something called as the pay as you go model. What does it mean, pay as you go? So suppose I have used the AWS tool or AWS product, which has given me some 8 GB of RAM and 12 GB of 12 CPUs for 3 hours. So I will be paying them the charges of 3 hours only. Okay. It's not like that I am permanently buying the hardware, and which is a lot cheaper. So it will save a lot of money. So this is the core idea, and that's how the cloud business started. This is something called as the cloud computing. You have a lot of physical resources, you buckle them or you join them and from a big cluster or a data center, and you host these services to others, and then others will utilize your resources and pay you some rent. Okay, so this is the cloud business. Now these tools gonna need hardware at any cost, right? Because without hardware there is nothing, there is no term of software there, right? So to get that piece of hardware, we will be reaching out to mostly Azure as well as AWS. So right now, if you compare, more than 80% of the market cap has been captured by these two tools or these two platforms. Platform is the right word that I can say. Okay, so platform is the right word. These two are the platforms. On top of these platforms, our applications will be running. Now, to run the application, we need something called as the Docker and Kubernetes that we will set up on top of these clouds. Okay, and these are the cloud resources. Azure is from Microsoft, AWS is from Amazon, GCP is from Google. These three are the sharks that we can say that are there in the domain of public cloud specifically. So there are the terms such as the public cloud, private cloud, hybrid cloud that we will understand later on. But these three are there. Out of these two are capturing around 80%, or we can say somewhere more than 80% as well. Okay. Out of that, AWS is holding more share than Azure. Okay. So yeah. So how the cloud is actually formed, what all the things such as virtualization that we will understand. Okay. Now our tools such as Docker and Kubernetes will be installed over our cloud. Now these tools are directly dependent on our cloud services. Okay. Now you understand, you have a Python application is developed, your Python application has been forwarded to Docker. Now from the Docker, your application has reached out to KTS or Kubernetes. To run the Kubernetes and Docker, you need something called as the cloud. And from the cloud, you will be buying out some resources and you will be running this Docker and Kubernetes on top of cloud. There your application will be running. Okay. So this process itself that you are seeing, it's a kind of CI/CD. Okay. Everything one is dependent on other. It's pipeline, right? It's pipeline, one after another. Okay. Now, right now, it's not an automated pipeline, but let's see now what are the things that we're gonna need to automate it, right? So once you understand something with respect to cloud, then we will start with something called as the Terraform. Now, if we go here, okay, just a minute, let me bring some water. Now, if we look into our AWS curriculum, this curriculum is ideally, I think, is shared to you. If not, please reach out to the volunteers. This will be shared with you. There are multiple resources that are there. It's not like that we will be directly able to leverage our RAM and CPU, right? There are some kind of layers that AWS, Azure, GCP, all three clouds have created. There are some of the technologies, some of the keywords that are there. Okay, we will understand this. What does it mean by EC2? What does EC2 offers? So there are multiple services. There is the load balancer that is there. There is the EC2 instances that are there. Route 53 is something, if I have to say, it's very much likely like your GoDaddy, right? Domain name hosting services, right? So there are a lot of services that are there that we will able to leverage through our clouds. Okay. Now there are a lot of concept, lot of services, more than 100 services that are there. And once you understand these services, then you will understand that creating these services might create some of the manual mistakes that are there. Okay. So suppose if I say you have to create 100 EC2 instances. So what does it mean by EC2 instance? Let's understand first. Okay. EC2 instance, or it might be virtual machine. What does it mean? So virtual machine and EC2 instance, both of these tools are actually something which provides you the part. Computation part in the sense they are actually providing you your PC, you can say. They are actually providing you your PC, or you can say uh, a service which actually responsible for providing the computing part, and this PC you can use for your own as well as you can create it as a server. Okay. Now, if you have to create a setup of 100 PCs that are there, you will be repeatedly doing same steps over the period of time, right? So now, if you understand, there are the chances we are humans, we might make some mistakes. Okay. So if we are making any mistakes, there it will create uh, actually a huge impact. So suppose there is a cluster where 100 PCs are actually linked with each other, and one of the PC is getting in trouble, it might create a chain of reaction and it will destroy the whole cluster. Might be scenario. We will understand this when we understand the concept something called as the spoof. Spoof is single point of failure. Okay, spoof is single point of failure. Now, to avoid this manual setup or manual usage of the service, there is a tool called as the Terraform. Terraform is something which actually automates AWS, Azure, and GCP cloud infrastructure. Okay, what does it mean? Infrastructure. Infrastructure is actually your resources. Okay, so AWS, Azure, and GCP is that something that will be automated with the help of Terraform. Now you will understand that the flow is like you have an application. To run that application, you need to reach out to the cloud. But if you need to set up an infrastructure in a better way, and if you have to automate it, you have to leverage the Terraform. Terraform will create your infrastructure on any of this cloud, and then we will set up Docker and Kubernetes on top of this cloud with the help of Terraform. Once that part is done, we will able to run our application on top of Kubernetes and Docker. Okay. Now let's proceed with the next tool that is there. So there is something called as the Ansible. Right now there is bit it's bit tricky to explain the role of Ansible here. Ansible is something called as the configuration management tool. Ansible is something called as the configuration management tool that will be there. Now, Terraform is something which is actually creating your server or your operating system or your PC. Okay. Terraform is actually responsible for creating a server. Server is nothing but your PC right now for the time being you consider it. Okay. Now, your server will have some software dependencies. Okay. Once you create a server, inside that server you might need to install Python, you might need to install any other software. Even if it's your PC, you might need to install some kind of games, right? Now there is a way where you can automate this installation part, installation of softwares, right? That you can automate. Okay. Now for the installation of these softwares, there is something that Ansible comes into the picture. There is a difference, there is a slight difference between the role of Terraform and Ansible. Terraform is something that will create your PC, and Ansible is something that will install the softwares on top of your PC. Okay, now understand in that manner. So Ansible is called as the configuration management tool, and Terraform is called as the infrastructure as a code, we can say. Okay, infrastructure as a code. Now, if we have to move, if we have to understand this overall pipeline part, we will consider in a way that we have an application will be running on top of cloud, or to run on top anything on top of cloud we need a Terraform will actually create the resources on the cloud. Once the resources is been created onto cloud, installation of these softwares will be taken care by Ansible, right? So Ansible is a very wonderful tool from Red Hat, and it has actually changed the market very much with the help of the way of working that it has. Right now, there is Ansible, and Ansible is actually responsible for installing whatever the dependencies your application might be needing. Now you have installed your dependencies. Now your application is there. Now there is the role of Kubernetes that will be there. Okay, actually, when we were discussing this, with the understanding that these tools, how these tools gonna placed first. Okay, these are the tools that we were going to use. Okay, so how these tools gonna placed on top of cloud, that we have understood right now. Now what is the role of these two tools? Okay, it is something Docker we have already discussed. It will actually place our application or package our application, containerize our application. Now there is a Kubernetes is something that is actually responsible. Kubernetes is actually something that is responsible to manage our workloads. Okay, with the help of Ansible, with the help of Terraform, you created a PC. With the help of Ansible, you have installed Kubernetes on top of your PC. Now Kubernetes is there. Kubernetes will actually help us to manage our workload. There are multiple techniques that Kubernetes uses. Okay, auto scaling is there, deployment, replica set. We don't need to jump into there right now. Whole sessions, the series of sessions will be there on this. But right now you understand that Kubernetes is also there. That will help us to manage our workload. Now consider in a way, so if you have to take an example of Geo Hotstar, right? Now to understand that example, let's say that they have a build an application using Python. Now they have written a code in Terraform that will actually create something on top of AWS and Azure. Okay. Now they have written code in Ansible that will install Kubernetes and Docker on top of Azure and AWS, right? Now the code that is there is in the form of packaged form, which is called as a Docker container. That Docker container will actually run on top of Kubernetes. So it's everything is interrelated. Okay. Now if you look carefully here, if you plug all these tools together, you will understand that there is a series of chains, or you will understand that right now, even if you can see here, there is the symbol of the DevOps which represents silos. Okay, interconnected things are there, right? Okay, it's not the it is not something which is actually breaking the loop. So to understand that part, you have to think in a way that with the help of these tools we will be creating an automated pipeline. Okay, and this pipeline, how we gonna to create an automated pipeline, we need help of some other tools, okay, which are called as the CI/CD tools. Okay, CI/CD tool, and we will be leveraging Jenkins. Jenkins is called as the CI/CD tool. CI/CD tool, these all the tools that we discussed, our Docker, Kubernetes, Terraform, Ansible, these are independent, right? Jenkins is something which will gather all these four and connect with one another. Okay. Now your Docker is connected with Kubernetes, Terraform is connected with AWS Azure, then your Ansible is connected with your whatever the resources that you have created on top of your AWS and Azure cloud. These things will be connected by Jenkins. Okay, Jenkins is actually something which will gather all pieces, connect them, and create a pipeline. So many of you might have heard that Jenkins is pipeline tool as well. Okay, right now Jenkins has huge market cap with respect to CI/CD. There are multiple other tools as well, but the conceptually the Jenkins, even if you understand GitHub Actions, GitLab CI/CD, everything is same. The conceptually is same, just the change in the syntax. Even if the DevOps is nothing but a thinking process. So at the end of this course, if you think that if I hand over only Python to you and I say with the help of only Python, without understanding of all these tools, still you can create a kind of automation. Okay, so that at the end of the course that you might able to understand this. Okay, so how DevOps is nothing but just a psychology where you need to think in a way that I need to just click one button and everything should be automated. Okay, whatever the tools that you use doesn't matter. There might be different tools that they than this. Okay, because every tool has some competitors, right? Terraform has a competitor called as the Pulumi. Ansible was having competitors like Chef Puppet. Kubernetes has also competitors. Competitors only change syntax, not the logic, not the core intention. Okay, so it's like that. Now the Jenkins is something which will plug everything in a place, and through one click of Jenkins you can make everything work. Now if you proceed ahead from the Jenkins, now your application is there. Now application is been deployed on top of Kubernetes. Application is running fine. Okay, now there is one risk. Okay, what if our application suddenly goes popular? How we gonna know it that our application is in a training? Yeah, definitely from the social media you will able to understand, but that will be very late to understand that your application is popular enough, right? So what I think is when your application has getting more traffic than usual, you should see some spikes in what you should see, some kind of graphs, some kind of pictures that represents that application is consuming more than expected, the traffic that is reaching out to our application is more than expected, the too many people are reaching out to us, then we can increase the capacity of application through Kubernetes, right? And if we are able to increase our capacity through Kubernetes and our application is able to and our application we are able to serve the traffic to our new incoming users, then it will be called as the great achievement, because we here something called as the auto scaling part that will be there. Okay, this is something which is very important. Okay, now understand, Star was earlier serving traffic around 1 to 1.2 crore people, right? Right now what I personally think is like they are serving more than 10 crore. Okay, they have made their system bigger. Okay, and it's not like that they this system is fixed, right? Even if there are less traffic, they are actually reducing the size of system. If there is more traffic, then they are increasing the size of system. And how they are able to understand they are having much traffic, less traffic, they are able to understand through the consumption of the resources, through resource consumption. Okay, resource consumption means they are able to understand through dashboards that we will create that will actually monitor our system, and generate some kind of graphs that yeah, your RAM consumption is going high, CPU consumption is going low. Okay, something like that. So if I have to show you and some images, something like that we will create. And even if it, I think this is too small, but yeah, something like this we will create, and which will actually help us to understand whatever the consumption. And if everything is looking that it's utilized more than expected, we should scale. So suppose if you have 10 GB of RAM and you are actually on a 9.9 GB that is already consumed, okay, before it reaches to 10, you need to increase your RAM, right? So what are the ways? And to understand that ways, you have to understand the cloud, okay? And to reach out to that step, we first need to make sure that we have something which actually help us to monitor first. First, we should know that our RAM consumption has been up to 99%, right? So here there is something that the cherry on the cake is like Prometheus and Grafana. Okay, so this Prometheus and Grafana is actually two tools set together because they are very much interrelated. These both tools help us to create the dashboard which actually shows the consumption. Now through the consumption dashboards, we can also, this is called something called as the monitoring. Okay, now we have our monitoring setup. If we are monitoring our cluster, if our cluster consumption is more than what we are expecting, then we should also get the notification. Notification is kind of alerting. It's not like that, hey there, right? It's not a simple thing. You should get an alert. It is the moment to act. So it's alerting. So there are the using the Grafana, you can say you can create the alerts. Now once you received an alert, you through the Kubernetes you will able to scale up, right? That's how everything is related. Also there is the role of SCM. Okay, it's source code management. Okay, now with respect to this source code management, here we are actually storing our source code for our project. Okay, now your Python code is actually part of source code. Let me show the arrow like this. Now let's understand one more time how everything is linked, right? Now your application code is actually placed into your source code management tool, which might be your GitHub, Bitbucket, anything. Okay, there are a lot of tools. Conceptually, everything is the same, yeah, but might be some syntax changes. Now your Python code will be deployed on top of Azure or AWS with the help of Terraform. Ansible will help us to create these, or these are two softwares, right? Tools is actually softwares. So these two softwares will be installed with the help of Ansible. Okay, and when we install these two tools with the help of Ansible, then there is the role of Kubernetes that will come into picture. Kubernetes will actually help us to run our containerized application. Okay, now the Jenkins will be there. Jenkins is actually something which actually connect every piece. So Jenkins will connect us from building a Docker image build to first step the Jenkins. It's like that. Prior to the Jenkins, whatever things I have mentioned will be connected to each other, and Jenkins will build a Docker image, will deploy a Docker image, will create an EKS cluster, will also install the will create and resources on AWS and Azure. Then Ansible will create some kind of Kubernetes cluster. Jenkins will deploy our application on top of Kubernetes. Some kind of auto scaling will happen. Till here, everything will be connected with the Jenkins, right? Now there is something which is an independent portion, right? This is completely independent. This will actually help us to monitor our system that we have created. And if there is something that is going wrong, we will get an alert. Alert might be at anywhere. You might get an alert on your Gmail. If you are using some kind of application, you might get an alert there, right? So that might be the cases. Now, these are the all the tools that we will be covering up. Okay. So let me walk you through the complete training. If you look here, there are these are the certifications that we will be covering up with the help of this training. These are the technical certifications. We will be covering up the syllabus with respect to these training certifications. And if you want to give an exam to these technical certifications, we will provide our assistance with respect to that also. Yeah. So AWS CSA we will cover, AWS Certified Developer Examination we will cover, Certified Kubernetes Administrator, which is one of the most demanding posts on the market. So this we also cover, Certified Kubernetes Application Developer. We will also cover this, Docker Certified Associate, Jenkins Certified Engineer, and HashiCorp Certified Terraform Associate. As well as, it is not mentioned here, but we will be also providing you Red Hat Certified Engineer training as well, which is responsible for Ansible. So 1, 2, 3, 6, 7, 8 certifications we will be covering. Yeah. So if you want to opt for examination, you can, and that you have to reach out to these providers. You have to register for the exam, and whatever the things that are needed to pass the examination, we will also help you in that as well. Okay. Now, if you consider there are these are the most of the AWS tools that we have also mentioned. Similarly, similar to the AWS, there are multiple services that are there into Azure. We will also cover that as well. Okay. From the databases, from the EC2, storage, computation, everything will be covered. There is nothing as such left over. Okay. Each and every part we will cover from AWS and Azure. Logging monitoring also we have, CloudWatch we will also cover. So you should go through this to understand. We haven't mentioned much details about the Azure because the browser will might exceeded than 60 pages, right? So, but the same thing will be covered, right? So you might be thinking that there are too many topics that are listed. Okay, once you start journey with me, you will understand that these too many topics will be covered in the duration of 3 months with the AWS and Azure. And one thing I have to say, the names are the different, the core concepts are the same. There are some minor changes you will able to understand with respect to two different clouds, but the core motto behind developing the service by any of the cloud is the same. So if anyone is developing a service for a database, may it be any cloud, name might be different, but the database will work same as the database, right? So that's how it is. So yeah, with respect to Red Hat, so we will be also teaching you the Linux part as well. Okay, Linux is mandatory, the silent with respect to DevOps. So we will be understanding the Red Hat Linux 8 as well. And yeah, many more Linux commands will be coming in your way. Networking, we will understand with the help of our theoretical as well as in a practical manner. For the Docker, we will touch from the Docker basics to advanced. Yeah. Git is something which is actually help us in managing the source code. We will understand various branching strategies, merging strategies, what are the things that we can use with respect to DevOps. We will also understand the GitOps as a, if we are able to cover up everything. I am also planning to touch something called as the Argo CD, which is not the part of the course, but which will help us to understand the GitOps. Okay. So then there is the Kubernetes part. Kubernetes is actually very complicated topic, but yeah, we will understand in a better way. Now after this, there is something that, yeah, with respect to the Kubernetes, we will understand the various deployment strategies, how application, you see your app, your cell has having many applications, which is getting updates on regular interval. So these updates are called as the release cycle, part of the DevOps. So you are seeing the update on your cell on a particular application because of the DevOps team that is there, right? So how this release cycle works, that also we will touch. Then, yeah, then there is something called as the Terraform. There is the details with respect to Terraform that is there. You can go through it. Terraform, we will understand from basic to advanced. You, in a single go, you will able to accomplish or pass the examination with respect to Terraform. Yeah, ideally you should opt for. It's cost wise, it's much cheaper than other, right? And then there is the Prometheus, Grafana, and the Python end to end. Yeah, we will understand Python with respect to OOP, design principles, connectivity with respect to database, Flask, Fast API, whatever you think, we will able to cover. And it's not up to like that. If a student has any recommendations for us or any topic he want to learn, he will definitely he should able to suggest us. We will try to include it as well. Okay. With respect to Azure, we will learn Azure in a comparative way because conceptually there are very less differences that are there. Okay, so we will learn Azure while comparing with the AWS. So that's how we will be doing that. And also, while we are learning throughout the batch, we will also be performing practicals with respect to capstone projects. Okay, and that capstone projects will be more of related to MLOps. So most of the guys, you might be aware of this term MLOps right now. So if you have applications, so suppose if you, anyone wants to understand that part, if you have application which is actually very much similar to ChatGPT, how we can build the applications like ChatGPT. In short, these things are related to MLOps. So we will understand, we will actually do a project with respect to this. Okay. So conceptually, there are very less terminologies that needs to be understand here, but yeah, it's one of the most demanding thing in the market. Yes. So yeah, that I think we are good with the time. Over to you, Diksha. Yeah. If anyone has any questions.
Sure. Uh, Thank you, Abhishek, and thank you everyone for being part of this uh, session or the webinar and sharing your questions, input. Okay, so we are happy to answer all your queries. So this is just a high level introductionary webinar which set up the context related to what you are going to be learned if you are planning to start your journey as a cloud engineer, DevOps engineer, or a data engineer. So inside this, we will be covering most of the cloud specific tool, including the AWS Azure, because we are getting the combined requirement. Some of the folks are interested in AWS and some of them are into Azure. So it's kind of a combined thing where we will be talking about more in both the sides. And AWS part, yes, is going to cover by Abhishek, and the Azure part will be covering by me. And here in this webinar, we have not talked about much on the Azure because primarily Abhishek will be delivering the sessions on AWS. But yes, I guess you are already aware on the Azure. We have taken a previous session also topics, and maybe if you're interested, you can drop a message. You already have our community detail or the email ID, so we'll share the curriculum or plan in person also. So, but yes, it's going to be a kind of a combined session. And if uh, I can see there are a few questions also in the chat. In that case, here I would answer okay. So first from the Ashish. I want to do the Python and Azure. Yes, here if you're starting with Azure, data engineering say Python and the SQL is the prerequisite. So we will be starting on the Azure. Then yes, as a prerequisite, there are some. Okay, so whoever is just, attending this session, there are some prerequisite study material also will be sharing. So because now here we're starting with the cloud, but you should be coming up with some background of the Linux, Python, SQL, these things. So some free learning material also will be sharing, and apart from that, once the session is started, we'll be also picking up those topics. But yes, you will be doing some brush up before coming in the session, so that's why. So yes, Python and Azure will be part of the curriculum in the session, Ashish. And what will be the next question? Okay. If no more, then I guess we are good so far till this point. And thank you, Abhishek, for joining with us and giving us the complete walkthrough about the plan, curriculum, and the entire program. So, and thank you everyone who has joined and be with us for this entire webinar session.
Thank you.
Thank you, everyone. And stay tuned for our next upcoming event or the next upcoming webinar. We'll be keep posting in our LinkedIn or in our community channel. So you might get the link in the description in the comment section. So do join, and then if any questions or anything, feel free to reach out in that. Thank you.
Thank you.